Hello everyone, my name is Iris.
My name is Amber.
The dataset we're exploring is US family and household wealth. We'll be surrounding our investigation on language spoken by each household and their respective income. After exploring the dataset, we found that the English-speaking households have a higher median income than non-English-speaking households. We're curious whether this difference is statistically significant. We'll be using the difference between the median of household income as the statistic, since average is greatly influenced by extreme values in the dataset. We would use a 10% p-value cutoff to determine whether the null hypothesis should be accepted or not. We went through the stages of analysis, hypothesis testing, classification, and linear regression. We first bootstrap the income of the two categories and see whether the observed value is within the 95% confidence interval of the bootstrap result. We did this for all of the observed data used in later procedures to ensure the legitimacy of the data. The null hypothesis is that there are no differences between English or non-English speaking households. The alternative hypothesis will be that English-speaking households have a higher income than non-English speaking households. We first used A/B testing on the two categories of data. Comparing the observed difference with the distribution, we came up with a p-value of around 0.06, which rejects the null hypothesis. However, we realized that the big difference in the sample size between the two categories would make A/B testing biased. We improved our method by first sample by random with replacement the same number of English-speaking households as the number of non-English-speaking households, which is 193. Then conduct A/B testing with the sampled English-speaking households and the original non-English-speaking households data. This time, the p-value was 0.1484, and the null hypothesis should be accepted since the result is larger than the 10% cutoff. We decided to further examine if any other factors resulted in this inconsistency. We decided to consider the region the household is located in. We divided the data according to the region labels, which are South, West, Midwest, and Northeast. After analyzing them using the improved A/B testing method above, only the Northeast region data yielded p-values smaller than the 10% cutoff. Thus, the null hypothesis is rejected only in the Northeast region. In other regions, the null hypothesis is accepted. These regional characteristics cannot be demonstrated if the data was to be considered entirely. Some limitations of this hypothesis testing would be that the bootstrapping result is not completely normal, as the data, especially the non-English speaking families, had a relatively smaller sample size, but not enough to hinder us from attempting to bootstrap the examples. We may not be able to reach the conclusion that the observed median is completely valid. Also, the four regions have different sample size, which may hinder us from maintaining the level of consistency of the bootstrap method.
Exploring the data and utilizing the conclusion we draw from hypothesis tests, we want to construct a case nearest neighbor classifier that could classify the language spoken in each household, depending on its household income and family income. Then we examine the accuracy of our classifier in each given odd case value in order to find the most accurate one. In order to do that, we first use 20% of the available data to be the test set and the rest 80% to be the training set. Examining the proportion of non-English families, we can see that its proportion in the test set is approximately the same as its proportion in the training set. This proximity suggests that we can use the test set to test the accuracy of our classifier with less bias. We first calculate the distance between the given test point and every point in training set. Then we identify case nearest neighbors and determine the majority household language spoken within the case nearest neighbors. For example, as you can see here, when k equal to 5, the result generated by the classifier for the first test dot is English only. Applying this process for the whole test set, then comparing this result with the actual language spoken, we get the accuracy of the classifier for a certain k value. Repeating this procedure for all odd k values under 10, we can determine which k value yields the most accurate result. One limitation here is that there is a large overlap between English and non-English speaking families. This makes the classifier harder to distinguish between these two variables. Also, for the calculation convenience, we filter out the non-family variables, which may lead to some inaccuracy of our classifier. After finishing the classification, we noticed that there might be a correlation between the household income and property value. Thus, we decide to run an actual linear regression prediction on the property value given the household income and test the validity of such model. Using the equations learned in class to construct the prediction mechanism, we draw out the yellow dots, which is the linear regression line based on the prediction. In order to test the validity, we calculate the correlation coefficient R, then compute and visualize the residuals. From the scatter plot we draw, we observe that most plots are clustered toward the right bottom corner, and there are apparently more negative points, rather than points randomly scattered like a random plot. Therefore, the linear regression model may not be the right model for this prediction. One potential limitation for this prediction is that we only know one prediction model, linear regression. However, for this dataset, this particular model is not applicable. Therefore, we might need to learn some more models to run the more thorough analysis. Thank you for watching.